Welcome to the Crazy Hat Chemist. So another video here on kinetics, another pharmacological example, in fact. Bam! So an applied pharmacological example of kinetics number 2. Let's check it out. So because there is a legal amount of the, because there is a limited amount of the enzyme to process alcohol in the human body, alcohol dehydrogenase, or otherwise known as ADH, the enzyme becomes saturated. Therapeutics and drugs, that is alcohol, taken in excess have saturable kinetics, which means that increasing the concentration of the drug does not increase the rate of metabolism. Again, because of the limited amount of the enzyme present. Graphically, this leads to a straight line plot of concentration versus time, which is typical of zero-order kinetics. So this is going to be a zero-order rate law in which we are going to be using for this problem. Suppose a particular person has a blood alcohol content, that's BAC, of 0.32%. How long will it take for that person's blood alcohol content to decrease below the illegal limit in the state of California? The legally intoxicated blood alcohol content in the state of California is 0.08% for persons of the age of 21 or older. Okay, remember, it's a straight line plot of concentration versus time, therefore it's zero order kinetics because this is a enzyme which is saturable, meaning you can add more and more, but it will not change that linear plot of that concentration versus time. Okay, so the rate constant for alcohol dehydrogenase, ADH, is K is equal to 0.17 moles per hour. Okay, this is the zero-order integrated rate law. That is, concentration at time 0 minus concentration at time t is equal to KT. So what we're going to do is we're going to plug in the values into here that we know of in this problem. Okay, so let's plug those values in. We know the rate constant. We are actually going to be solving for a particular amount of time here. So we've got our initial concentration at 0.32%, okay, minus our 0.07%. Now notice that that number was not actually in the problem. The number that was in the problem is 0.08%. But I'm trying to figure out what is below the illegal limit here. So that number is just below the illegal limit. Okay, then we got our rate constant on the other side of this equation here at 0.17 moles per hour, and then that's times t. So we're going to be solving for t, that is time. So we're going to do that little subtraction on the left-hand side and then divide by the rate constant. That will give us our time, and then here's what we get for that. So our time is 1.5 hours. So that's how long it's going to take to decrease that blood alcohol level from 0.32 to 0.07%. Okay, so a little note on this here. The note is any alcohol content in the blood, that is any blood alcohol content above 0% according to the state of California, leads to impaired driving skills. Therefore, the recommended blood alcohol content in the blood for safe driving is 0%. Furthermore, there are multiple factors which affect the metabolism of alcohol in the blood, okay, and therefore would affect the time to reach the blood alcohol content percentage calculated in this problem above. Some of these factors are, but are not limited to, the following: sex, age, race, weight, food consumption, biological rhythms, exercise, alcoholism, and drugs which affect the enzyme alcohol dehydrogenase. These are some, but not all, of the contributing factors affecting alcohol metabolism in the human body. So don't take that value that you just calculated there as an absolute, okay? But it is a relatively good guesstimate in terms of the time. All right, I do have something more for you, so don't go away, okay? I have a little bit of elemental humor and kinetics humor combined here. So why do chemistry teachers drive so fast? Well, because they're always flooring it. Okay, and I got a good picture here for you, me driving my car right here, Of course, you can see that that's a Pagani Huayra, and you notice that my license plate is Crazy Hat 1. Notice that. Okay, another joke related here. Okay, why do chemistry teachers drive so fast? Well, because they only have a half-life. That's the kinetics part of that humor. Okay, I am the Crazy Hat Chemist, and I got, of course, another hat for you. And this is a hat that my son made for me many, many, many years ago. How do you like that? Give me a thumbs up if you like that video. Subscribe to my YouTube channels, and I'm going to see you next time for more cool chemistry videos. And we got more kinetics videos to go. So I'll see you next time. Bye for now.